Hi, in this presentation, I am going to present our work titled Enhancing Public Procurement in the European Union through Constructing and Exploiting an Integrated Knowledge Graph. The outline of this presentation includes introduction, the platform, knowledge graph provisioning, advanced services, uptake and adoption, lessons learned, and finally conclusions. Public procurement basically concerns purchase of services, works, and supplies. It's a very large market. It makes up 14% of the European Union's GDP. Therefore, governments need to be efficient in delivering services, ensure transparency, prevent fraud and corruption, and build healthy and sustainable economies. For this, good quality, open, and integrated procurement data is required. There are already several directives by the European Union in place, and these directives already led to creation of national and EU-wide public procurement portals. However, there is a huge technical heterogeneity. There are no common data formats and models for representing and exchanging such data. Several ontologies have emerged, like PPROC and LOTET2, but there has been no wider adoption. To this end, our goal is to develop and implement a platform and a knowledge graph composed of REST APIs and ontologies to publish, curate, integrate, analyze, and visualize European Union-wide, cross-border, and cross-lingual procurement knowledge graph. Let's start with the TheyBuyForYou platform, which is composed of data providers, an ontology network, and a platform architecture. Regarding the data providers, we have two main data providers, namely OpenOps and Open Corporates. They gathered, extracted, preprocessed, and normalized data from hundreds of data sources. OpenOps is our main data provider for the procurement data. They have 685 data sources, and 569 of them comes from the European sources. They have over 3 million documents dating back to 2010. And this data is available through an API using Open Contracting Data Standard, OCDS. OpenOps basically uses Tender's electronic daily data feed as a main data source. TED is dedicated to European public procurement and publishes 520,000 procurement notices a year. Their second data source is the transparency initiatives of the individual countries, and they basically get this data through scraping, web scraping. Our second data provider, Open Corporates, is actually our main data provider for the company data. They have more than 140 million company records from a very large number of jurisdictions. And this data is also available through an API using its own internal model. They basically get this data from national company registers and other regulatory sources. In order to represent these data sets, we use two ontologies. Actually, we developed them. The first one is OCDS ontology for representing procurement data, and EU Business Graph ontology for representing company data. OCDS ontology is composed of 25 classes, 69 object properties, and 81 data properties created from the 4 main OCDS sections and 11 extensions. Core classes include contracting process, plan, tender, award, and contract. EU Business Graph ontology is composed of 20 classes, 33 object properties, and 56 data properties. Core classes include registered organization, identifier system, person, and dataset. When it comes to architecture, in the figure we provide a high-level overview of the architecture. On the left-hand side, we have the ETL processes that are used to incorporate the data sources into the knowledge graph. On the right-hand side, we provide the main data storage mechanisms, including a triple store for storing the generated RDF, and a document store for the documents associated to the public procurement, such as tender notices, award notices, and so on. And their URLs, the URLs of these documents are accessible via a specific property called RDFC also. For those cases where a URI is available, for the original data sources, that is from OpenOps and Open Corporates, such a URI is also provided in the knowledge graph using the OVL same as statement, so that users could actually get additional information about tenders and companies with a different license or access rights, for example, for commercial use. Now let's look at the knowledge graph provisioning. That's in two folds. The first is data ingestion, and the second is data publication. For knowledge graph provisioning, we implemented a daily routine for downloading and ingesting procurement and company data into the knowledge graph. The first step is to download procurement data from OpenOps, which takes 1 to 2 minutes per day. Then we try to match suppliers appearing in the procurement data provided by OpenOps against company data provided by Open Corporates. We do this through the reconciliation API provided by Open Corporates. Whenever a match is found, we download the corresponding company data in JSON format as well. That takes at most 1.5 hours per day. Then we enrich the JSON data, basically with the company identifiers. That takes around a minute per day. Then we convert the JSON data to XML, and we do this conversion because of the limitations in JSON path. Then we map XML data to RDF, which takes less than an hour per day. And then we publish the RDF data to database. On the left bottom, you will see the configuration of the machine that we are using for this process. We use Python as the primary scripting language, RML mapper as the mapping tool, and finally Apache Jena Fuseki as the SPARQL engine and the triple store. As of September 2020, we have 129 million statements, 1.35 million tenders, and 1.58 million awards. And we also have 100,000 companies matched in the awards as suppliers. As regards to data publication, knowledge graph is published through a SPARQL endpoint, a REST-based knowledge graph API, which we call Core API, a cross-lingual search API, which we will talk about in coming sections, and an API gateway as a single access point for all. A REST-based knowledge graph API, Core API, was built using the R4R tool based on the velocity templates. Currently, our API only returns JSON objects, but additional content negotiation capabilities and formats are to be provided. In the figure, you use a Swagger, let's say, interface for our API, where actually one can play and test the API. Now we are going to talk about advanced services. We provide several advanced services, but in this presentation, we are going to talk about anomaly detection and the cross-lingual search. Let's start with the anomaly detection. Public procurement is particularly open to corruption and fraud. Therefore, analyzing the procurement data might give us hints on possible patterns that may represent fraud or corruption. However, analyzing such large data set manually is not feasible. Therefore, we implemented several existing machine learning techniques on top of the knowledge graph to detect some anomalies and patterns. Those techniques include supervised learning, like decision trees, unsupervised learning, like clustering, and statistical analysis. We did this analysis together with the Slovenian public administration. I will give one example to such analysis and one case actually, that is with the decision trees. In this case, we are trying to find what makes a tender successful. The definition of successful tender comes from the ministry in this case, but that could be redefined. Basically, we consider a tender process successful if there were more than one bid. That means there were some competition. We basically let the domain experts to select the parameters like the number of bidders, number or the tender value, or the depth of the tree, and so on. And according to our analysis, we see that a tender is successful if the public institution who opened the tender is small, that is, has less than 1,375 employees, and if the bidding is done in groups. In that case, there is 70% of chance that there will be more than one bidder. Of course, that was only one example, but we have found many other interesting patterns and anomalies by analyzing the data. Some of that you can find in the paper. And we developed this system, and this system is also available online. When it comes to cross-lingual search, procurement documents often are published in the official language of the corresponding public administration. And usually the documents in the local language are typically much more longer and much more detailed than their translations in other languages. Therefore, we developed a service for finding documents that are similar to a given one, independently of the language which it's made available. The service is based on the use of unsupervised probabilistic topic models and based on cross-lingual labels from sets of cognitive synonyms called synsets. The method is basically evaluated in several document retrieval tasks by using a set of documents previously tagged with the Eurovoc categories. The results are quite promising across the languages with a performance close to 0.8 in terms of accuracy. Again, more details of the evaluation you can find in the paper, but in the figure you see an example based on the test interface that we developed on top of our system. Basically, we have given a text in English and asking for the corresponding similar documents in Spanish. Regarding the uptake and adoption, we made the data, ontologies, and the platform open along with the source code and the online systems, linked to the online systems, so that others can use and contribute to our, let's say, platform. There's a catalog available for which the link is given. Basically, through this catalog, you can get the data, you can get the schemas, core APIs that we have developed, all added value services and tools that we developed around this platform, including the code source, the running system, documentation, and so on, and as well as the data sources in both original format, that's JSON, and also in the RDF format. The Knowledge Graph API and the Knowledge Graph are used by the Spanish company OESIA and by the city of Zaragoza, Spain. The anomaly detection tool is used by the Ministry of Public Administration in Slovenia, and the cross-lingual similarity search is used by the Italian company Servet. The users include civil servants, citizens, and companies, especially SMEs. As of August 2020, over 3,700 queries have been submitted to system APIs. As far as the lessons learned concerned, the knowledge graph enabled easier and advanced analytics, which was otherwise not possible. The existing semantic web technologies and tools scaled well for ingesting and provisioning large amounts of data. The RESTful approach that we used was quite useful for bringing the linked data and non-semantic web application developers. The only problem that we faced during this process, or one of the major problems that we faced, was the quality of original data sources. There was a lot of missing data, duplicate data, poorly formed data, erroneous data, and absent data fields that could be partially solved by new regulations and also by using a standard ontology network like ours. Regarding the conclusions, open public procurement data is available in silos today with heterogeneous data formats and models. To alleviate that, we provide the platform with core components and advanced services to integrate, publish, and analyze procurement data based on ontologies. The Knowledge Graph platform and its components already have some adoption and cases presented that it's useful. We aim to expand the Knowledge Graph with new data sources, such as for spending data, and promote the developed tools for wider use. Before ending my presentation, I want to announce that we will also have a demo on this paper, so you could get more actually insights, hands-on insights regarding our platform and the Knowledge Graph. Thank you very much, and we are open for questions.